Hello team, welcome back. And today we are going to discuss about the demo on custom resource definition. We will see a short demo, and in this demo we will create the custom resource definition and we will use it. We will also see the multiple version lifecycle of that resource, and we will see few more other important information related to the custom resources in Kubernetes. So let me go through the configuration of the custom resource definition first. So team, over here in my Visual Studio Code, this is the repository which we are using for this exam, and we already provided the git location of this code multiple times in this course. So over here we have a directory called application underscore environment underscore configuration underscore and security. In that directory we have the another directory called CRDs. Let me allow to open the CRD. And in the CRD you can see I created a file called demo CRD definition. Right? Let's open this. So in my CRD, I created a file called CRD underscore definition. Right. Let's go through this definition. You can see over here we created this definition, and this is the same file which we used in the earlier lecture whenever we was discussing about the overview of the CRDs. We have the API version API extensions.k8s.io.1. Then the kind is custom resource definition. The metadata name, we are taking it as a combination of the plural and the group. The plural is basically defined over here. You can see this is the cron tabs and this is the group. We are going with a single version right now, which is v1. In my schema we have the three properties: cron specification, image and replicas. This is going to be scoped in a namespace. The singular is cron tab. We can use this on the CLI to access the resources which is being created or attached with this particular resource definition. The kind is going to cron tab. So whenever we will define the new resource, we need to use this kind cron tab. And if we want to use some kind of shortcut on the CLI, we can use the CT simply instead of the cron tab. Right, these things we already discussed. Now let's go to the Kubernetes cluster and execute this CRD underscore definition. So here I'm on my Kubernetes cluster and I will execute kubectl apply -f and define my file location. And over here you can see I'm defining my file location: application environment configuration security, CRDs, and CRD underscore definition.yml. Let's hit enter, and this will register your custom resource with the Kubernetes. See, we are getting that custom resource definition dot API extensions dot k8s.io cron tabs dot stable dot example dot com created. So over here we have registered the custom resource. And as we are aware, because over here we have exposed an API endpoint, because everything in the Kubernetes is basically managed by the Kube API server, and this is the API endpoint we are exposing for my custom resource. So that must be available with the Kubernetes API server. So let's try to find out if that thing is available with my Kubernetes API server or not. So we will execute a command kubectl API-resources, define grep, and define your resource name. What is my resource name? That is a cron tab. Let's hit enter, and you can see the cron tabs which have the alias CT, and this is the API version stable.example.com v1, and this API is true, is available with my API resources. So as soon as I have created this custom resource, that is available on my Kubernetes API server, and I would be able to create the resources which will use this particular Kubernetes resource. Similar way, if you will search for the another API resource like pod, you can see you have the pods over here, right? The the shortcut is PO, the API version is v1, and that is true. Similarly, if you will define the deployment, you will see the deployment is also registered with the Kubernetes API resources. The deployments, the shortcut is deploy apps v1 and true, right? So in the similar way, we have created the custom resource called cron tabs. This is the short form or alias which you can use on the CLI. This is the API version, and this is true, right? Let's clear out the console. Now what we need to do, we can create the resource using this particular custom resource. Now what we can do, we have registered the custom resource with my Kubernetes. Now we would be able to create any object in the Kubernetes which will use this particular resource. So let's go through the definition. Over here I created another file CRD underscore resource. See, we are using the API version stable example.com v1. This is my API version for my custom resource. The kind, we are using cron tab, capital C, capital T. The kind we defined over here, that is the same kind, right? In the metadata, you are using the name. In the specification, we are using the cron spec and image. If you will go to the resource definition, in the schema, we have defined the cron spec, image and replicas. Till date we are only using the two parameters, the cron spec and the image. So now you can assume that how you can define the specification, because that specification is registered with the resource whatever you created, because that specification is registered with the resource whatever the resource is registered with the Kubernetes, so that you are able to use that specification. Now let's do one thing. Let's go to your cluster and execute this resource kubectl apply -f, and this time we are going to use crd underscore resource.yaml. Hit enter, and you can see the cron tab stable example.com my new cron object is created. If you will execute kubectl get cron tab, hit enter, you will see your object. In the similar way, if you will execute kubectl get ct, you will also get your object. Why we are able to get it on the cron tab and ct? Because as per my definition, as per my resource definition, I have defined the cron tab in a singular and shortcut ct, so that I'm able to access my resource. If you will define any other format, like you will define capital C and capital T, then you are able to do it. If you will define just cron, hit enter, and you will get the error, because there is nothing like that, right? So this is the way how you can register your custom resource like the other resources or the native resources available with the Kubernetes, and how you can create the object on that custom resource. So over here, using this particular YAML file, we are not doing any execution. We are just defining, we are just creating the virtual resource which is using this particular custom resource definition. So this particular thing is not going to execute the cron job, no, that is not something like that. We are just showing that this particular object is stored in the custom resource definition, right? So we are just showing you that how you can create the custom resource definition and how you can create the object using that custom resource definition. Let's move further. Let's describe this with the hyphen o void. So we will define get ct hyphen o void, or you can define hyphen o yaml. You can see we are getting the API version stable example.com v1. The kind is this metadata annotations. In the annotations, you can see we are getting the API version, which is this. The kind is cron tab, metadata is annotation. This is the name, this is the namespace, and this is the specification. So we are getting the complete information about my resource. Let's clear out the console. Now let's do one thing. So you remember we defined the three things: replicas, image and specification. And I told you that whenever you will create the resource, that resource will be validated against this particular schema. So let's do one thing. In the CRED resource, we will modify the name and we will call it object hyphen dummy one. And we will define another resource, and over here let's call it name equals to, let you, and you can define any name, like we are defining level up 360. So what we are doing, you can see this name we don't have in the specification, because we have only three things in the specification. So we will see that once this will validate the schema, Kubernetes be able to create this resource, or we will get the error. I will save my file, go to my terminal, and try to create this resource again using the crd underscore resource.yaml file. Hit enter, and we are getting the error. What is the error we are getting? It is saying unknown field name in this particular specification, right? So it is saying that in your resource, whatever the resource you are creating, you are using the specification name, but in my resource definition, the resource definition object you created in the Kubernetes, I don't have any such information. I don't have any such field. I have only three fields: cron specification, image, and replicas. The same error you are getting over here. A known field name in cron example stable v1 cron tab spec. Right. But we can avoid it if you will execute this command using this parameter, validate false. It means don't validate this particular YAML, just create the resource whatever we are submitting. So whenever we are putting hyphen hyphen validate equals to false, in that case the object definition is not going to validate against the schema of your Kubernetes resource. Let's hit enter, and this time you will see the resource got created. But here one more thing I would like to show you. Let's execute the kubectl get ct-o yaml and define your name like this. Let's get the YAML of this resource. You see, whenever we are getting the YAML of this resource, if we will go to the specification, we are only getting the specification cron and image. We are not getting the third specification which we defined, which is a name. So although the Kubernetes created this resource without validation, but the resource which is not the part of your specification, that will not be entertained in the Kubernetes object, and they will be ignored and your resource will be created. Right. So I hope this cleared your doubts regarding the validate false, that how the Kubernetes validate the resources, that how the Kubernetes validate the configuration, what are the things we define in the specification, do they have some kind of limitations or we can define anything. So we have seen a couple of things. Let's move further. So let's do one thing. We will open the CRD definition and we will execute the multiple versions. So we will copy this version section, go to the insert mode, and we will paste it again. This time we are calling it version v2. Right. So earlier we called the version v1. This time we are calling version v2. And over here in the version v2, suppose we are defining the replicas minimum and maximum count. So we are calling minimum 1 and maximum 10. So what we are doing, basically we are restricting the user, that user will be only able to create the number of replicas which in range between 1 to 10 whenever they are using my custom resource, and the API version is v2. Now whenever you are doing this, and if you are using the storage, then you can only keep the single API version storage true. So over here we need to make it false. Right. Let's save this, go to your cluster, and I will again execute this file. So we are going to execute the CRD underscore definition again. Hit enter. What this will do, this will update your existing custom resource whatever is created in your Kubernetes. You can see this is configured. Now let's do one thing. So we have this definition where we have the name. Let's remove this, and instead of the name, let's take the replica. So we are defining the replicas. Let's take the replica over here. We are calling the API version v1, and let's define the replica 20. Right. We are using the cron object dummy 1. Save this, go to your cluster and apply your file. Let's remove the validate false as well. So we are going to execute the crd underscore resources dot yaml. Hit enter. You can see this is configured. Let's get this kubectl get ct and define -o void. Hit enter. So you can see whenever we are defining the replica, although that doesn't matter, but we are able to create that or configure that resource. Let's do one thing. We will modify it and we will define the version v2, because soon we have defined the version v2, and over here we are restricting the replica between 1 to 10. So let's see would be able to execute this or not. Whenever we are using the version v2 and we are executing replica 20. Let's go to your cluster, again execute the same command where we are going to apply the crd underscore resources dot yaml. Hit enter and see we are getting the error. Cron tab new dummy 1 is invalid specification replicas, invalid value 20. spec replica in body should be less than or equal to 10. So over here you can see, using the single resource, we are basically supporting the two API versions. Now you can understand why the cron job and job are basically able to deploy using the version v1 and version v1 beta 1, right? Because that resource definition is supporting the both versions, right? So this is the thing. We understand that how the APIs are supporting the multiple versions, and with each version you can change your specification, you can change your properties, you can limit the users, you can define the new properties, and you can ask user to validate against the new API version instead of the earlier version. So over here you can see you are able to manage the complete development life cycle of your feature, right? Let's do one more thing, that how you can deprecate your API, because we have seen multiple time whenever we are using the Kubernetes, and if we are using some API version, sometimes we see a deprecation warning in the Kubernetes. Although Kubernetes is not restricting us to deploy that resource, but it is showing the warning, right? Let's see how that warning is displayed. So if you want to show some kind of warning with your version, suppose we have created the version v2, so we want to show the warning with the version v1. So what you can do, you can define the warning like this: deprecated true, and you can define the deprecation warning. And we are defining the deprecation warning message: example.com v1 cron tab is deprecated. See example.com v2 for instructions to migrate to example.com v2 cron tab. Right, let's save this. Go to your resource definition, update this, and suppose we are going to create the resource with the version v1, because we have attached the warning with version v1, so we should be able to see this warning. But before deploying your resource, let's update your custom definition. So we are again going to execute the CRD definition YAML. So please make sure we have saved this file before apply and apply it. So this time we are deprecating the version v1. Now let's save your CRD resource and execute your CRD resource. So we are executing the CRD resource which is using version v1. So we should get some kind of deprecation warning this time. See, we are getting the warning, although it is able to change my resource, but we are getting the warning that this version cron tab is deprecated, and we have the new version of the cron tab which is v2. So team, this is the way what is the custom resource definition, how you can create the custom resource definition or register the custom resource definition with the Kubernetes cluster, how you can manage your custom resource definition, and how you can create the object using that custom resource definition. So apart from the custom resource definition, this particular demo have other lot of thing. Right now you are able to understand the complete picture of the Kubernetes world, how the Kubernetes object are basically working, how they are registered, how the what is the meaning of the APIs, how the Kubernetes is deprecating the APIs, how the Kubernetes is managing the multiple APIs of a single resource. So there is a lot of thing in this demo. I hope you are learning the good content. Thank you team. See you next time.